guys, so we have something a bit different for you this week. We actually have a user submission, which is really cool and is something that we encourage. So you know, if you have samples that are, you know, you have questions about, or it was something that you're looking at during triage and kind of tripped you up a bit, you weren't positive how some specifics were working, you know, definitely reach out, and it's something that we're open to taking a look at and doing a video on. So yeah, submissions are great. We love submissions. So this came in from a user, and the context around it is they were seeing a phishing campaign that included a password protected document. It was a docx file, and within that password protected document it contained an obfuscated Visual Basic script file, a .vbs file. Malware authors really have two techniques to trip up an analyst. The first one is they're going to do some form of string obfuscation, and that's really to mask the calls and the objects, you know, what variables do within the script file. So if you've ever triaged any of these or done any sort of analysis, it usually doesn't contain, you know, any line breaks. All the variable names are just junk, and any of the objects that it's creating are obfuscated right up to the point that they're needed. And then the second way they generally try to trip up an analyst is through obfuscating the control flow. So if you've seen a script file, it's generally procedural, right? It's going to run from the top to the bottom, and it's going to start calling the subs or functions that are defined, or other, you know, standard library features of the scripting language, and it's just going to go on its way. But you know, maybe they're using go-tos, or they're starting to do, you know, a sub calls a sub procedure, so it's not really obvious what's going on. And when you combine those two together, you can get, you know, a really a really bundled mess of just, you know, text that you have to deobfuscate. So what we're going to do is just actually go through this sample manually. There are tools that you can use to really optimize some parts of this, but I think it's important to really understand, like, you know, how this works. So then if, you know, a tool fails, or if you're running something in a sandbox, you can just really quickly dive into the script and say, aha, you know, this is what it's doing, or this is the portion that I really need to focus on. Okay, so let's dive into the document and really see what we have. Now, although this was a user submitted document and we know that it contains embedded script objects, we'll go through just a quick triage process I usually take when looking at new or unknown documents. With Office files, there's generally a few ways an attacker is going to execute code. So obviously, you know, the document can contain an exploit. The document could contain macros. It could contain an embedded object, which we're going to look at an instance of that here, or it could even just contain a link to, you know, some sort of malicious website, or to download something, right? Now, to really mitigate against these, you know, an exploit is obviously something that's not going to be, you know, obvious to us just by looking at it. Maybe looking at the contents, we could, you know, see that there's something weird going on, and we might be cautious. But to protect against a lot of those, just, you know, don't open this up on your computer. Use a VM with a snapshot. Ideally, you know, don't have network or internet access enabled, so that way if something does get away from you, you can just revert the snapshot, and there's no harm, no foul, and then you know potentially the type that you're dealing with. So there's a few ways we can go about doing this. I'm going to start with a Linux console, and that's just, you know, my preference is to use some of the command line tools that are available on Linux, and then we will switch back and, you know, do some of the same tasks on Windows. So it's not a, you know, one or the other. You can use either one that you're comfortable with, depending on, you know, if your org even allows you to have Linux VMs or not. So we can do the triage in both ways, and what we're just looking for is, you know, is this, you know, what does this document contain? So we want to confirm that, you know, it does just contain embedded object files. So we can take a look quickly here. I'm just SSH into a server. And we have our document, and generally what I'll do is I'll create a subdirectory just called ex or something, and I have the document copied into it. And in the case that we're dealing with the modern format, so .docx, we know that it's just a zip container that contains XML and other metadata and files used to render the document. So we can actually just extract out the contents of the file and take a look at what's actually in it really easily. So I'll create that subdirectory and then extract everything out and just use the tree command to get a quick overview of what the document looks like. So we can see here right away we have an embeddings directory and these OLE object 1, 2, and 3.bin. This is where embedded objects reside within a document, but then it doesn't matter which Office program you're dealing with, it would be contained under these embeddings. We also don't see any of the artifacts that would indicate this as macros, so the VBA project.bin as an example, and also the fact that this has the docx extension. If you try to take a macro enabled document and save it or rename it to docx, Word freaks out and just won't open it. It'll say it'll give you a warning saying you have macros in a macro free document, I think it is. So we've confirmed that this definitely contains embedded objects, doesn't contain any macro scripts or whatnot. It could still contain an exploit, we have no idea. We're running on a VM, so if anything really bad happens, we will hopefully be okay, but I think we got this. So we can just quickly change into the embeddings directory and take a look. So we can just let's do an MD5 sum of them all, and we can see that all the files are actually the same. So for some reason the actor embedded the same object a few times. So strings is an instant responder's friend, as you probably know. So let's just do a strings in one of the files. And sure enough, we're seeing a bunch of VBA code, and we also see some other object metadata here. So just a quick pause for anyone that hasn't had to work with or deal with Office documents containing any sort of embedded files or malicious content. The way it works is if you insert an object into Word or any Office document that it doesn't have a default server for. So in this case, evil.vbs is inserted into this Word document. Word has no idea how to handle a VBS file. It just does not understand what a VBS file is. It's actually inserted as this packager object, and what that does is it stores some additional metadata about the actual file that was inserted. So it'll actually include the default source. So if in this case evil.vbs was included from c/temp, it would include that within the metadata of the OLE file that's stored, and it'll also include the default extract path. So by default that's %temp, and that would be generally c/user/the user. So you can get some additional metadata from these packager objects, and then of course it would include the data of the embedded file. Now if a user interacts with an embedded object in Office, in this case Word, what it actually does is it just tries to run the file. It just says, okay, run evil.vbs, and then it just will use the default handler for that file extension to actually execute or open that file type. So Word, has no idea what VBS is, but you can still embed and interact with, any sort of file type just using the default handler in the file extension. Now, just to demonstrate quickly some of the metadata or additional data that's available within the packager format, I'll just run a script called psparser on one of these OLE objects, and we can see some of the additional information that's contained. So it includes, the name or the label, so document part.docx, the spaces.vbs. that original path again, the extract path, and then just some additional details about the actual embedded object, so the size and the hash of it. So we'll link some tools that you can use actually to interact with these files and quickly extract them. But again, see, if we're dealing with scripts, strings, strings is our friend, right? Like it works completely fine. Okay, so now that we've confirmed that our document, does just appear to contain embedded objects, let's take a look at it on the Windows system and see some different ways to extract the contents from there. In this case, we saw, if it's a script file, just running strings on one of the OLE objects, you can pull it out. There's also a number of tools that we can use from the command line to pull these out. But on Windows, it's actually interesting because it's really, really easy to extract out these embedded files. So here's our document again. Now I don't have Word installed on this VM. And that's okay if we're dealing with embedded objects, because we don't need any of the Office features. We don't need macros. Really, we just need to support the specific file format, and we need to be able to support packager objects, which WordPad does entirely out of the box. Visually, of course, it's not going to look great, but we don't need that. We just need to pull the objects out. Now, what happens when you open a file which contains embedded objects is that it will automatically extract those scripts or those files out to %temp, wherever you have your temp directory located on your system. So if we open this quickly, we can see immediately we have the 3 files written out to the temp directory. So one easy way to take a copy is just Control C, Control V. If I close this, it's going to clean up those other files, like the files that were automatically opened, and I have my dash copy of the file. So that's just one quick and easy method to pull them out. Also what I can do is just drag this over, just drag it out, and then we have a copy of our VBS file. Now, like we were saying before, is that these aren't going to run right away. Even if I double click this, it's going to ask me, do I want to actually run this file? And I don't, so I'll hit cancel. But it's not something that we have to be afraid that these are going to run automatically. Obviously, if there's some sort of exploit that changes that can somehow automatically trigger or execute some of this code, that's a different story. But by default, embedded objects, the user has to interact with them, and they have to accept the prompt. So there'll generally be that prompt that pops up that says, are you sure you want to interact with this file type? It could be dangerous. So there's really 2 clicks a user has to do to execute one of these script files. Now, one thing to note, if you're dealing with some sort of embedded object that you're not really that familiar with, you don't know what the default association is with it, you can actually run the association command. In this case, we're looking for VBS. So VBS is considered a VBS file, and then we can look at ftype and say what's associated with VBS file, and it gives us what's the actual handler for a VBS file. In this case, we know it's WScript, and it's going to pass in the first arguments and then any other arguments that's been passed to it. So now that we have, we know the association with VBS, and we've taken a copy of it, let's move it into a directory. We can start actually working with the script file and figuring out what this thing actually does. So I've just created a directory called c/analysis, and what I'm going to do is just rename this quickly to call it, stage 1 .vbs, and this is just a naming that I know this is the very first stage, how it would be delivered to a user. I haven't done touched it or edited at all, And generally when I'm dealing with script files, if I'm doing them quickly, is I might make a few copies as I'm going. So that way, you know, if a regex gets away from me, or I'm doing some sort of automation to clean up the script, and something goes wrong, I can just go back to the previous file and fix it and keep going. So just a quick pause to do an overview of VBScript and how it's interpreted. There's really a couple main things you have to understand when analyzing these file types. The first one is that VB, you know, like any other language, has procedures, and they have two different types. They have something called subs, and they have one called functions. And the main difference between these two is that functions will actually return a value, where a sub will just execute code contained within that sub. The other thing is that they're only executed if they're called or referenced, either from another sub or from the root or the base level. So when you're triaging scripts, is even though there might be, you know, dozens of different procedures like subs or functions, some of them might just be junk code that they throw in because they don't have a reference either from the base or the root level, or they're not referenced from any other sub. So if we look at our example quickly, this would be processed, and the first actual call that would be executed is this entry line at the root or the base level of the script, which would pass control up to our subroutine entry, you know, which would execute some code, and then it has a reference to F1, our function. F1 would you know, continue execution in it. It would set F1 to a value, which would pass control back up to the subroutine, which would go on processing until it ends, and then control would either be passed back out to the root, or it would call another function and it would keep going. So it's important to note that, you know, root level elements are entirely procedural. The first one that's referenced is the first one that's going to be executed, and then the order of the functions and routines really don't matter because they can be called in any order whatsoever if they're called from another sub or another function. So with this, we can really see that you know, an attacker can do a lot to really confuse the control flow. They might hide some of these root elements between different functions or subs. They might add in a whole bunch of just, you know, nonsensical subs that are never called, or they might call some that actually don't do anything, right? I've seen that a lot as well. So there's really a lot of leeway, you know, like in any programming language, just to start adding in, you know, contents that either doesn't make sense or is never executed. So just understanding how the control flow works and how control is passed between subs or functions and executed at that base or root level is really important to being able to quickly analyze a file manually if you have to do that. So what attackers have to do, or just a developer really has to do to interact with the OS, is use the create object function to create an instance of a COM object, and that's done by passing the prog ID or the program ID of your desired object and setting a variable that would contain the instance of that object. Then in your code, what you would do is you could call, you know, if this was shell, you could call shell.execute and then pass the, you know, the proper parameters to that actual command. Now, what you will generally see in any sort of malicious scripts is that there's a few areas here that they can actually still use obfuscation. So obviously the variable that they set the object instance to be is not going to be called shell, right? It's just going to be some junk characters that we have no idea what it is. The prog ID is generally also obfuscated, so instead of this being a string, what it'll be is it'll be a function that actually deobfuscates some sort of string, and that return value would be the actual prog ID of the object that they want to instantiate. Now they can't obfuscate the actual command on the object, but what they will do is they can't obfuscate any of the parameters they pass to it. So, you know, if it's a shell execute, they can mask using functions the exact command that they're trying to execute. Obviously, if it's a web request or some sort of network request, the actual destination and what they're doing, again, would be functions that return the proper clear text of what the parameter should be. But as an analyst looking at it, we really have no idea until we go through and figure out how they're obfuscating those strings. But we can see that you can quickly scan through and identify functions that will be interesting, because this create object and, you know, known commands can't really be obfuscated. So generally what you'll see is you know, garbly-gook that's some variable dot run or dot open. And as soon as you start getting more familiar with these, you'll recognize, oh, that's probably this object. They're doing, you know, some sort of web request, or maybe they're going to do some shell command. Generally, you'll see three really common types of objects that they use. There's going to be some web request to download a payload of some sort or do something. There's going to be some shell request because they're actually going to want to execute or run some commands. And then there'll also likely be some sort of file system object because they're going to want to move files or check something. Of course, that's not all inclusive, but those are three real common objects that you're looking for and that are used in a lot of different samples that I've seen. So now that I've extracted the script file, it's time to take a look at it and find out what this thing actually does. So I'll just open it up here in a text editor. And the first thing I like to do is just set some sort of syntax if it doesn't have one. So we'll pick JavaScript because it's probably fairly close. And then what we can see right away is that we just have a wall of text here. If this was JavaScript, we could use something like JSBeautify, and it would add in, you know, new lines and do some indentation based on the code to make it, you know, pretty easy to read. Because it's VBScript, there's a couple online tools. We'll link to them that'll do tabs. But it doesn't do that good of a job as far as you know, adding in spaces and whatnot. So you could just write you know, some macros to do this in whatever text editor you use, and go through and just add in some new lines to figure out, you know, where the functions are, where the functions and subs are, and what code is actually at the root level. So once we've gone through and added in you know, breaks between all the different procedures, we have to look and find where's any of the code at the base level. So what's actually going to be executed when the scripts run. You know, going down to the bottom is usually a good start. Is there anything after all these procedures that are defined? There isn't, so then we know it's probably hidden between two of the procedures as a way to sort of you know, trick up an analyst of how this thing actually runs. So we scroll up. So we see this call here, which would call the sub below it. We'll just scroll up to see if there's anything above it. There's not. So we just have this global variable. So then we know right away that these are the two things that are going to be actually run first, and this line here actually calls this subroutine. So we can just indent the code in here, and let's just rename this to entry to make it easier, and so we remember. Then you can probably see this as well. We have these lines that look really similar, just all over the place, right where we are. I'm curious to know if this is referenced anywhere. You know, it's not. This one we know there's nothing else at the root level, so that gives it away. Let's check this one too. So it looks like this is you know, a technique they use to obfuscate the code to just add in junk lines. This is definitely a good spot to add in or save a copy because we don't know for certain yet that none of those are used. It looked like none of them within that area, at least within this snapshot, are actually referenced at all. So it's a good indication that that's just, you know, inserted junk code. So already we have a pretty clean entry point here. It looks like it sets a value, loops through, incrementing this variable xqv. It then does a check if xqv equals this other one, and calls two different subs. So, you know, again, if we read through this a bit, we can see that this here will always be true, right? So they've just added in some more code to complicate it. So let's just remove this and the if. And already we can, you know, we have a pretty clean entry point now. We can see that the first thing called is this line here. That calls this sub that we've renamed entry. That calls, you know, two additional routines. So let's take a look quickly at what this QH7 function is. It's right below. So let's do this. It again looks like it has these this junk put in. And it's really not apparent what it does yet, but we can see this call, I'm guessing to a function, because it's being, right, in this case it's actually being passed as a parameter to this other sub, and in this case it's actually being set as the value. And then it looks like it's calling another function called cc. So let's just quickly look at where cc is. No. Oh. I think I just passed it. There we go. So let's just clean this up a bit since we're here. So we can see that it is setting some value. Again, we see this ev call, and then it's calling .run on that value, whatever this object is. So this is actually a really good way to discover what function is doing the string obfuscation. We can see down here in this cc function, but then again in our entry point and the other sub that's called, we have this reference to ev where it looks like we have a hex string and then another parameter of some characters. And scrolling up, we can see this again and again. So this is like one of the, you know, the real easy or obvious indications that ev is probably our main string deobfuscator. So if we scroll up to ev, here we go. It is a function. Let's remove some of this junk. And we can see, again, it's doing a for loop, looping through, and finally setting ev to some value. So this here, I would definitely say that this is probably our string, what's being used to deobfuscate the strings. So what we can do is just write a quick script to be able to pass all the strings into it and really figure out what this thing's doing. So now that we've identified what looks like to be the deobfuscation function, what I'm going to do is just save a copy of it and call it stage 2. That way, if we did get it wrong, or if we end up editing the file and it doesn't work anymore, we can just always revert back to this point and start from there. Then what I'm going to do is create a new file, and we'll save it as, we'll call it deob.vbs. And we're just going to write a simple deobfuscation routine within Visual Basic Script. So that way we don't have to understand exactly what they're doing to obfuscate the strings, because really it doesn't matter to us right now. We just want to really see what the script does. If for some reason we do need to know what that is, we could always, go back into our deobfuscation script, because we'd have all the components, and then really drill into, how are these strings being stored and encoded/encoded. So let's just look quickly about what EV references. So the first thing I can see, add some line breaks in here, is this called a VPF2. So let's do a search for space VPF2, and we have a function here. Let's remove these, and it looks like all VPF2 is just a proxy to the char function. So in our deob, instead of like importing that, let's just rename this to char. Again, this to char. Then what's next is this LP9. So let's search for LP9, and it's right here. Let's remove that. Remove this. And it looks like LP9 is just calling mid. So again, in our deob, let's just rename this to mid. Now, if you aren't familiar with Visual Basic Script, these are mid and char are built-ins. So I know that, and I'm putting this in just so we don't have the we don't have as much code. But if you weren't sure, there's no reason why we can't just copy this entire function in and leave it as is. So we could just as equally do this into our deob and not rename it to mid. You can do it either way, but because I know that mid is part of the standard features or functions available within Visual Basic Script, we could just rename those. So let's go to G, whatever this one is. No. And again, so this is just this is just being a proxy to a built-in command. So let me copy this. I won't rename it in our EV script here, just to show you both ways work. And it's something that you would see as you look at these files more and more, what you can do with it. So we won't rename this one. Let's do J1X. I think we might already did J1X. No, we didn't. So here's an example where it's doing something, to the values passed to it. So let's just copy it out. J1X we want. We have a len. VPF2. Ooh. So that was char. And we have one more. MV. So again, this is doing, some sort of OR on the values. So let's just copy it in because, really it doesn't matter. Now that we have this in, that should work. What we want to do is actually write out to the console our deobfuscated value. So we can just do wscript .echo. And what we want to pass to that is EV. And then in EV, what we want to pass to it is we want to say wscript .arguments 0, and then wscript .arguments 1. So what this will allow us to do is call this script deob.vbs. Again, like we went through, these will all be ignored, and the first line that's executed will be this one. And what it should do then is call EV with our two parameters, and then echo that out to the console or to Windows. Okay, so let's try this out. we'll go to entry and then this QH7, and QH7 calls this with these two parameters. Oops. So you could probably see how you could script this as well and just process the entire file at once. We're not going to do that. We're just going to step through it just to show kind of how you can uncover the functionality and really step through the program. But if you're starting to do a lot of these, there's definitely a lot of opportunities to either use existing tools or just write some custom scripts that would quickly rip through a file based on the specific string deobfuscator. So let's see if our deob VBS is there. So it's going to give us an error because we didn't give it any parameters. What we just want to do is make sure these are two separate parameters. So if we run this, we can see that that's actually passing this command. Now by default, VBScript will use a message box, like a modal message box, for any sort of string echoes or things like that. So what we can actually do to get around this is use cscript, which is the console script manager, and then we can start copying things out. So then in here we can say, hey, you're actually called this, and then we can see that cc is called with this value, and then it looks like it's just a 1. 4946 minus 4945. So let's scroll down to CC. So this is our value here that's coming in. Let's just rename this to command. So it looks like this is going to call run a command. So let's take a look at what this string actually is. We can go back up here and just do cscript deob. Let's paste in, and it's translating to VBScript shell. So we can see that this here is actually, it looks like it's setting OF to be VBScript shell, and it looks like what they've done is, let's take a look at XY. What does XY do? Here we go. So we have the create object. So like we covered before, they can't really obfuscate this create object. Like, it has to be in there somewhere if they need to create or instantiate one of these COM components. But what they could do is, like, really make it difficult to find out at first glance what it's doing. So instead of being right here where the call is and we see VBScript shell, it's actually referencing it from another function. So that's cool. We can see that this is actually, so CC seems to be like it's some sort of command runner. So it'll get a instance of the VBScript.shell components and then run the command through it. And then this must be the param. So in our case, it was a 1. Let's rename this to param. And 9650, 9650. So this is just 0. Okay, so that's interesting. The first thing it does then is it calls, ping 250 times to the Google DNS IP. And this is probably, if I had to guess, this is, a way to do some sandbox evasion, because this might take some time to do and just slow down processing of the script. So let's take a look at what this is doing next. So once that happens, it's going to then call this next sub, this OVH. So we can then say cscript our deob. Hey, we get an IP. That's cool. So whatever this does, it takes in, well, not IP, a URL. It takes in a URL as a parameter. So that's interesting. Let's take a look. Oh, it looks like this is a pretty big function too. So let's just indent this quickly and remove. Let's remove some of this junk. Oops. You can see that it seems to be every 2 lines. So it's obviously some sort of script they ran on the script to obfuscate it. That's interesting. Let's see if we did that right. Hopefully. Okay, let's see where it happens now. So we know GD here. We can see it passed right here. Let's call this past URL. Past URL. Now, if you're just quickly trying to get IOCs, you can see we already have one that you could pass on to someone else and say, hey, has anyone hit this? You know, do we have any logs of it? If someone actually interacted with the file. This call to the EV, we can see it's actually doing a reference to the variable PAES rather. So let's just copy that in so we can copy this entire string out. And let's take a look. So script deob. Paste it in. VBScript.shell. Okay. So we have another shell object, and because this one, you know, there's a lot of functionality in here. Let's rename this. So I'm going to just say, oops, let's say shell obj. Shell obj. Rename this one. Shell object. Just to make it a bit cleaner for us to figure out what's going on. So it's trying to get some sort of environment variable. Let's see what it is. So you could probably see how this could be tedious if you were doing it entirely manual for every script you're triaging, but you know, that's probably not going to happen. So you can really write some automation around this, but sometimes, you know, that fails, and it's good to know what's actually happening. So it's calling environment. It's calling our shell object on environment, and it's passing in process. And what are we doing here? App data. Okay, so we are whatever W8 is. Oh, it's this thing. Process app data. Okay. So we, you know, it's probably going to store the file there. What's this one going to be? So let's just copy this over so we can more easily deobfuscate it. Oh, here we go. We have the actual network request now, or well, component that'll do the network request. So we can see that this object here is going to do the web request. So let's just do a find and replace on this and just say web rec. There we go. Close that. So we can see it's going to get the location of where app data is. It's going to then use Microsoft XML HTTP instance to make a request to the past URL that we have. Seeing a lot of these, you could probably guess what this is going to be. It's more than likely going to be a GET or POST request. If you're familiar with the format of open here, and it's a GET, so we can just say, let's just change this to GET. So it's going to do a GET request to a past URL, 287, and then 0. So then it's going to send the request. It's going to check if the status is, so negative 408 plus 608 is 200. Let's just put that in to make it a bit easier. Let's indent this. So if it is 200, the request is successful. It's going to then call 6130, 6134. It's going to call something with 4, I guess. Weird. And then set this to 5402. Oops. So let's check quickly what this does. Oops. Sub. So it looks like this might be another delay of some sort. It's basically doing a loop while the timer is less than PPV, PBPVV, and it's just doing a tight loop. So that could just be there for some anti-analysis, or it might just be junk because it would tear through it pretty quickly. I guess depending on this value here. Alright, so let's go back up. You're not interesting to me. What is kind of cool though is that if the request status isn't 200, so if the request status doesn't succeed, it's calling open again. So let's see, this is probably get. Actually, that's oops. So this is kind of cool. So we can see that each string, even though this is probably going to be a GET request, each string is obfuscated using its own key. So we pretty much know now that we have, hex encoded, a hex string, and then we have just some sort of key that will decode this string. Dun, dun, dun. Okay, yeah, it's another GET request. And where is it gonna go? So this is something interesting that you can get into with automation. And did you cover all the code paths? So we have another fallback URL. So we can see here, just with the script, if it went through and you analyze this dynamically, and that first URL was valid, and you got a response from it, you would never see this second code block, and you wouldn't actually be able to download it unless you either went through it statically, or that first location was down and then it hit the second location. So it is always something to be cautious of, is that you know, automatically running this is great, it's fast, but you also have to be cautious because there might be, you know, some uncovered code that you don't know about, and if a user you know, executed, say, this script after the initial analysis, so the first payload location was down and it did that fallback, it might you know, you might miss that initial interaction going out from the user's computer. It's cool. This is a cool example. E36. So we're just setting 200 again. So if the status is 200, then this variable equals 5402. Okay. And this just seems to be, so if either of the web requests actually work, it's going to call this function with the response body. So now let's see what it actually does. Okay, so we have our sub here. So we can see it. Looks like it's instantiating another object. We can actually do this. Let's rename this to create object. Replace all. Just paste this in. See what it's doing. This is probably something to, I'll guess, write it to disk or execute it maybe. Okay, this is to write the file. So create a instance to ADO-DB stream. Then it's calling open, setting the type here to 1, and then writing the content. So we can see here this is actually the incoming contents is AQ1. So let's say just response body. Something actually you might see that can be common is if the location that they're downloading, say PHP log was from, is just on some you know, host with a compromised site, you might actually get back like some 404 page or something. So the request was successful if they don't set you know, the 404 type, and you just kind of get back you know, static HTML instead of this actual content, or a proper error code that would actually not step into this part of the code. So it's kind of interesting. And then it saves it to this A8SF. Where is that? That must be our... Okay, that's the global variable we have. Okay, here we go. So we have, it's going to be saved into the file name app data. Let's look at VPF2. So it's going to do a char of whatever that's equal to. And FD. Where's FD defined? Okay, FD is a function. So it's just going to return some, you know, semi-random value. So it's going to be a char. and then 2 semi-random values here, whatever that would return. I'm assuming maybe between 0 and 60. Okay, so it's going to write that. It's going to append something to it. Let's take a look. The extension .pmw. I'm guessing PM. 2248 and then 2. Also, if you ever are curious about what these do, they are pretty well documented in MSDN specifically. So, for instance, a save to file would be a method from ADODB stream, and you can look up what these parameters are. This is probably some sort of type, and then this is the actual file name. So then it's closing the file and it's calling this other sub that's right below it. That makes it easy. So let's just indent this quickly. Yep. And again, we see our CC here, which we know is going to execute something. So at this point, we can probably, pretty certain it's probably going to execute what we downloaded. But let's see where this goes. That's interesting. So what we have is it might be what we downloaded might be a DLL. Let's see what this is. Oops. There we are. So this is adding .riw. So again, FD was that's that random, quasi-random the second. So it's adding A8SF is our default location in app data, I believe. Yes, our file. So ta equals that, something random plus RIW. Okay, let's copy this value and see what it is. Run DLL32. So definitely what we're looking at here is we've downloaded a DLL, not an executable. And it looks like we're going to use run DLL32 to execute it. It then looks like it's calling another function here. Let's see what this is quickly. Our file extension again, .pmw. And then it's passing in ta, so this other thing. So it looks like it's passing in our original file, and then this renamed one where it's appended, a couple other, I'm assuming, numbers to it, and then RIW to it. So let's take a look what LFU does. Okay. So the first thing we'll do is remove some of this junk. You can see here too some of the methods that it's calling on the actual component instances. So this is something, create text file, open text file. We have our call to create object, which is just sort of a wrapper proxy for the actual create object. And then we have a loop here that's writing it out. I believe VPF2 is the wrapper for, VPF2. That's the wrapper for char. So it's looping through and it's writing out character by character. Okay, so let's see what this is. Scripting.file system object, okay. So it's using this to interact with the actual file system, as we can see. Oops. Now, if you are ever curious, you don't know what something does, we could just say, take this as an example. Let's just look up scripting.file system object. Right away we can see MSDN reference. And then we want to go to methods and say we're interested in this open text file. Let's look for open text file method. And then we can start to see the different arguments it takes, right? So it takes a file name, and then it takes a mode, create format. These look to be optional. So it's usually really easy. MSDN has, all these documented. So if you aren't certain about, what a specific component does or what a method or a property of a component does, it's usually pretty quick to say, just put it in Google or whatever engine you use, and search for it on MSDN. So I just want to check this quick because I think it's input file and then output file. Yeah. So let's just rename this to input file. Oops. Let's rename you to input file. Replace that, and then let's just say out file. Okay. So it's going to create, it's going to open our input file. It's then going to create the output file. So this loops through our input file, calling a read, so it's going to read character by character. It's then passing those characters to the MV function, which we know is doing an OR, and that OR is 103. So it looks like this is just simple. It's just doing an OR on the file, and then writing it to our new output file. So then we know that the original input file actually won't be flagged as a DLL or executable. It has gone through a layer of obfuscation. So then let's go back to our LFU. We can then see in the sub here that what it's going to do is pass in WU, so run32.dll, quote, our TA path, which would be the updated file with the RIW extension. And then it's going to pass in this WMH, which is the end of the run32.dll with a comma DLL register server. And then 0 again. So it's going to pass in 0. And that looks like that's it. So just a quick overview of the functionality of the file now that it's deobfuscated. First, what I'm going to do is just create a new file where we can put our initial IOCs as we go through the various bits of functionality of the actual script file. So we identified it has a single entry point based on the fact we only found one command at the root or base level of the script. Within that sub, it calls two additional subs. The first one pings an IP address 250 times. So that's something we know anyone that opened the file, their system is going to exhibit this behavior. It will then call the next sub with the parameter set to a URL. So we know that it's going to interact with this URL. Within that function, it will get the location of app data for the system, and then it will do a HTTP GET request of the URL that was passed into the function. So we could just sort of update this to just say HTTP GET against the first URL. Now, if that status code is not 200, what it will do is it will actually deobfuscate and send a secondary request to another URL, again using HTTP GET request. So then we can say HTTP GET against this second URL. Now, if either one of those succeeded, so we can see here this variable tsx set to 5402. In both cases, if the status code is 200, it passes the entire response body to this other function. So let's go here. In here, it actually writes the response body out to a file under %appdata with the extension PMW. So we can say PMW extension under %appdata %. And now we know it's using the function second to return some quasi-random, I'm guessing digits or numbers. So we don't really have to be explicit exactly what the file name is because it's probably going to be different for each system. But we know it's going to be under %appdata, and we know it's going to have the extension PMW. So once it writes the file to the initial response body to our new PMW file, it will call this next function, the KVC, and that sets up the running and the deobfuscation of the actual payload that the script downloaded. So we can see here the string DLL register server. We also see that it's going to call run32.dll, and then it also sets another variable with the extension RIW. So then, we can go back here and also say .riw. It's like this. And we can just put decoded. It passes both the input and the output file to this other function LFU. Oops. Let's say LFU. Where it creates the secondary file, opens our input file, and loops through basically character by character, doing an XOR with the value set in MJ0 here. So 103, which I think is a G. So then we know we're actually going to have two files on disk, depending what the actual payload does. And then we're going to have a call to run DLL32 riw DLL register server. So, you know, we've been able to build, you know, a good number of at least initial IOCs if a user did interact with this file and where this thing is going to write out, and both network and some on-disk indicators. So at this point, generally what you would do is actually, you know, grab the payload if you haven't already and start some analysis on it, because again, it's going to have a whole host of indicators of, you know, did it run? It might clean up these script files if it knew what dropped them. So, and that's it. You know, we've gone through the file, we've identified all the core functionality of it, what it does both on disk and on the network. So I hope you enjoyed this walkthrough. Again, if you have samples or questions, definitely hit us up. We'd love to do some more of these user submissions. They're always a lot of fun. And as always, keep exposing the mechanics behind the malware and stay curious. Thanks.